invasive species are a big part of human impact in the world. Species have been obviously moving around since the start of species, between water bodies, between land masses, between continents, blowing on the wind, swimming in the ocean. Species get around. That's what we do. But humans have really stepped it up a notch as far as the number of species being transported and the distances that they are transported. So we are having an impact on the world via invasive species. There are four things that I think about when I think about what might make a good invasive species, a good invader. And, with species being transported around the world all the time, with humans, it's pretty evident that most of them either fail to thrive in their new environment or become just sort of a naturalized good citizen of a new environment. And it's just those few that seem to really take hold and explode in population that become issues for us. And I think of these four things. Four. One is high reproductive rate, make a lot of babies fast, make a lot of propagules in the case of plants, baby plants, seedlings, or clones. Has to be able to thrive in a lot of different environments, be a generalist or phenotypically plastic. Number three, good disperser, has to be able to move around or send their babies far. And fourth is competitive advantage, something. So in the case of Spartina, John mentioned a few. One of the most poignant to me was that nothing here eats it. So free from any kind of herbivory, any kind of predation, it has a huge advantage over our native species. Yeah, an example I like to think about is, let's take the common house mouse, Mus musculus, and a wolverine, Gulo gulo, here. So let's think about high reproductive rate. Mouse, absolutely. They can make a lot of babies fast. Wolverines, no. Are they generalists? Can they thrive in a lot of different places, a lot of different resource sets? Mouse, absolutely. They eat lots of things. They can live in lots of places. They are tolerant to lots of different environments. Wolverine, no. They're specialists. They only eat meat. They're evolved really specifically for mountainous environments. Good disperser. Mice they can travel far themselves, but they are also really good at hitchhiking on human craft, so they can move around really well. Wolverines, they really excel here. They can move really, really far, really quickly, just under their own power. And competitive advantage, well, that's an interesting thing to think about. I guess it would be dependent on where we're thinking about these organisms landing. I could get it really speculative right now, but I'll just cut to the chase and say that mice would be good invasive species and have been. Wolverines are not. Thankfully, we don't worry about an invasion of wolverines. That would be terrifying. In the world of invasive species, there's a lot of talk of biocontrols, which is the introduction of a predator or herbivore or pest or whatever it is from that plant's native range, or that animals or fungus, whatever species it is, from the native range, that could bring that species back into balance, either eradicate it or just coexist with it in such a way that the populations were significantly reduced and it became a good citizen, basically. I love the idea. It's such an elegant idea. And there are examples of it working really well. My favorite is there was a prickly pear invasion in Australia. A species of prickly pear from the Americas was brought to Australia in part for living fences. They make good good fences. They're really unappealing to think about crossing. And cochineal production, which is a beetle that only lives on prickly pears that, when smashed, releases a red dye that was big in the textile industry until we came up with artificial dyes and other sources. So in Australia, this cactus got loose. It became densely populated in many areas, like this photo shows. And as a part of the eradication efforts, they brought in a moth from the cactus's native range. And the specificity of this moth is indicated by its name. It's Cactoblastus cactorum, likes cactus. And was a major success in a relatively short period of time, just a few years. The moth exploded in population and almost eradicated the Opuntia population, the prickly pear population. Huge success. Um, and it's not hard to find examples of the opposite of biocontrol of flops that have not worked. And the one that I think of most often was a attempted biocontrol of spotted knapweed. Huge populations, it can outcompete native grasses. It really is harmful to ecosystems in the Mountain West. There have been innumerable attempts through every venue, manual pulling, sheep eating, chemical treatment, many different biocontrols. One of the biocontrols was a little fly the size of a fruit fly, genus Europhora. Maybe you could say it's cute for a fly. But these were released into spotted knapweed populations in Montana. And not that many years later, there was a huge rise in the number of cases of hantavirus. Let me connect some of those dots. It totally blew me away. So Europhora flies lay their eggs in the seed head of knapweed, and those eggs hatch, and the maggots come out, and they start eating seeds like crazy, and they fatten themselves up on seeds before they hatch and become the next generation of flies. And the idea was that the maggots would eat all the seeds and just destroy the spotted knapweed's capability for spreading because it would have no more seeds. And what actually happened was that it ate most of the seeds, but spotted knapweed produces like 1,000 times more seeds than it actually can use. And so most of the seeds being gone didn't hinder its spread at all. But what there was then was a whole bunch of fat, juicy maggots sitting in these seed heads, which mice love. And so the mice would cruise around these spotted knapweed beds, climb up, and eat all these maggots. And there was a huge mouse population explosion. And a lot of those mice ended up living in people's cabins in rural Montana. And with higher mouse populations, the incidence of hantavirus in the mouse population goes up. And there's more mice, and more of the mice have hantavirus, so people started getting it more. And there was other effects too. There was a increased population of everything that ate mice, so raptors, birds, and foxes and weasels as well. But there's that complex adaptive system again. It felt like a good idea to hunch in this Himalayan blackberry patch for this talk, because it's one of my favorite invasives around here. It is totally damaging to ecosystems. It can really form like gnarly thickets that exclude native species and other useful, like good community members. But gotta say, love these berries. All right, bye.